AC circuit containing only a capacitor. So here we are going to consider a circuit containing a capacitor connected with that of an alternating source. Here this is the symbol of the capacitor. Here the capacitor is connected with a alternating source Vm. Now the instantaneous value of the alternating voltage is given by V is equal to Vm sine omega t. Vm is the peak value of the voltage. Now let Q be the instantaneous charge on the capacitor. So the EMF across the capacitor is Q by C. So this can be written as V is equal to Q by C. Now we can apply the Kirchhoff's loop rule. What the Kirchhoff loop rule says, the algebraic sum of potential difference in a closed circuit is 0. So in this circuit we can write V minus Q by C is equal to what? 0. So V is equal to what? Q by C. Here V is the voltage across the alternating source, and here Q by C is the EMF across the capacitor. So V minus Q by C is equal to 0. V is equal to what? Q by C. Now we can rearrange it. We can rearrange here Q is equal to VC. Okay. Now I am going to substitute V is equal to Vm sin omega t, and we are going to get Q is equal to, for V I am substituting as Vm sin omega t. So Q is equal to C Vm sin omega t. Okay. Now by the definition of current we can write I is equal to dq by dt. Current is charge by time. So I is equal to dq by dt. For I am going to substitute for Q d by dt of CV sin omega t. So we can write C Vm as outside and d by dt of sin omega t. So what is d by dt of sin omega t? Sin cos omega t into omega. So this can be written as C Vm omega cos omega t. Now for my convenience, I'm going to write it as C omega as 1 by C omega. So this and this are same. I is equal to Vm by 1 by C omega. And cos omega t can be written as what? Sin 90 plus omega t. So that is sin omega t plus pi by 2. So I is equal to Vm by 1 by C omega sin omega t plus pi by 2. So the instantaneous value of current I is equal to Im sin omega t plus pi by 2, where Im is equal to Vm by 1 by C omega, where Im is called as the peak value of the alternating current. Okay. Now, from these two equations, we can go for finding the phase angle. Here V is equal to Vm sin omega t and I is equal to Im sin omega t plus pi by 2. Now here you can see for voltage, the phase angle is omega t. For the current, the phase angle is omega t plus pi by 2. So here the current leads the voltage by an angle of pi by 2. And the voltage lags the current by an angle of what? Pi by 2. Okay. Now this can be drawn in the phasor diagram. So here we can see the phasor diagram and the wave diagram. Now this is your wave diagram. In the wave diagram, the alternating voltage is starting from the origin. That is V is equal to Vm sin omega t. But the current is starting ahead of the voltage. So the current is starting at an angle of pi by 2. So the dotted lines represent the previous cycle. So here you can see the current is starting before. Okay, so the peak value of current we are not getting at the same time. Now here for the phasor diagram, the voltage is represented by the vector OA. So this represents the peak value of the current, value of the voltage, and the current is represented by what? OP, that is the peak value of the alternating current. Now what is the difference between the current and the voltage? It is 90 degree. It is 90 degree. Okay. Now here we have to go for capacitive reactance. Capacitive reactance is nothing but the resistance offered by the capacitor in the circuit. So according to the previous equation, the peak value of the current is given by Im is equal to Vm by 1 by C omega. Now I am going to compare this with the equation of the resistor circuit, that is Im is equal to Vm by R. Now here what R plays, the same role is played by what? 1 by C omega. Okay. So 1 by C omega is called as the resistance offered by the capacitor. So we call this as what? Capacitive reactance. We call this as what? Capacitive reactance. So Xc is equal to 1 by C omega. Xc is equal to what? 1 by C omega. Now this equation can be written as Xc is equal to 1 by C omega. For omega, I am substituting as 2 pi f. Now here for an AC circuit, the frequency is not zero. So as the frequency increases, the capacitance reactance will decreases. As the frequency increases, the capacitive reactance decreases. Or as the frequency decreases, the capacitive reactance will increases. But for a DC circuit, the frequency is what? Zero. That is for DC current, the frequency is zero. So applying the frequency as zero. So you'll be getting 1 by 0. 1 by 0 is equal to what? Infinitive. So a capacitive react circuit offers infinite resistance to the steady current. It offers what? Infinite resistance to the steady current. So the direct current will not flow through the capacitor. So that is what? The capacitor blocks the DC and allows only the AC. Since the capacitive reactor offers what? Infinite resistance to the steady current, it will not allow the steady current to flow through. It will allow only the AC currents to flow through. So we call it as what? This capacitor blocks the DC current and allows the AC current. Okay.